Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wala. So in the last session we have started the kinematics. So in kinematics we have started the motion in a straight line. So where in lecture 1 we covered the basics like what is distance and what is displacement, what is velocity, speed, average velocity and average speed. So and how do we get the velocity from the displacement time graph, and how do we get the acceleration from the velocity time graph. So these all we learned in the last class. So in continuation to the previous session, so we are going to cover few numericals based on the previous session, and then equation of motion for uniform acceleration, where we are going to see some standard results which you have to remember directly so that you can solve the questions easily in the competitive examinations. So as usual, whatever the disturbances are there around you, so just avoid them for next 1 hour or 1.5 hours. So be with me and start writing the class notes, and most importantly at the end after lecture completing, so just spend 10 more minutes to write the short notes. So that's very important. Write the summary of the class in the last 10 minutes. Okay, so chalo guys, let's begin the session. So first let's see this question. So what's the question says? See here, a particle of unit mass undergoes one-dimensional motion such that its velocity varies accordingly. Velocity is given. See here, what is the function of velocity? V of x is equals to beta into x to the power minus 2n. So where beta and n are the constants and x is the position of the particle as a function of x is given by. So see here, so we have to find the velocity. So velocity is given. So what we have to find? So we have to find, I guess, the acceleration. See here, so find the acceleration. No, yeah, find acceleration. So question given wrong. So find acceleration. Write the question. Find acceleration. Okay, chal. So let's start here. So first, velocity is given as a function of position or displacement. So what's the equation that we have seen in the last session? So whenever the velocity is given as a function of displacement, to find the acceleration we have acceleration is equals to v into dv by dx. Acceleration is equals to v into dv by dx. So same thing you can use it here. So see here, so acceleration is equals to v into dv by dx. So now acceleration is equals to, in place of v, what we can write? Beta into x to the power minus 2n into d by dx of v, velocity. So where we can write beta into x to the power minus 2n, beta into x to the power minus 2n. So now acceleration is equals to, so let's see, beta into x to the power minus 2n into, so beta is a constant which comes out, so let it be. And what is the x to the power minus 2n differentiation? So minus 2n into x to the power minus 2n minus 1, x to the power minus 2n minus 1. Clear this part? Chalo. So now let's do the calculation part. So pause the video and do along with me guys. See here, so then here we can write acceleration is equals to, so beta into beta, so let's write beta square, so send it outside, and then so write minus in the starting, so beta square into 2n into x to the power minus 2n, x to the power minus 2n minus 1. So let's do this way, x to the power minus 2n into x to the power minus 2n minus 1. So then I can write this as, so minus 2n beta square into x to the power, so these two will be added, minus 2n minus 2n minus 1, minus 2n minus 1, right? So now, so we can write the acceleration is equals to minus 2n into beta square into x to the power minus 4n minus 1. So check the option, minus 2n beta square minus 2n minus 1, no. So minus 2n beta square x to the power minus 4n minus 1. Option B is the correct one. Clear? Understood the concept? So whenever the acceleration is given as a function, velocity is given as a function of displacement, If they asked you to find the acceleration, use this formula. So what is the another expression for acceleration? So it is a is equals to dv by dt. So when to use that one? When velocity is given as a function of time, so to find the acceleration, a is equals to dv by dt. But whenever the acceleration velocity is given as a function of displacement, to find the acceleration, a is equals to v into dv by dx. Clear? Chalo. So let's move further. So now, till now, we solved the questions related to if the displacement is given, if displacement is given as a function of time. Okay, so then to find the velocity, so what we did ds by dt, differentiating the displacement with respect to time, right? And then, so whenever velocity is given as a function of time, so if we have to find acceleration, so what we did, so the differentiating the velocity with respect to time, right? So that means from displacement to velocity and from velocity to acceleration, so we did differentiation. So ds by dt will give the velocity and dv by dt will give the acceleration. So this part is clear till now. Now the question is, what if velocity is given and they ask you to find the displacement? And what if acceleration is given, they ask you to find the velocity? Or where acceleration is given, they ask you to find the displacement directly. So what's the procedure? So the forward procedure is the differentiation, right? So now the reverse process is the integration. Simply, if you have to find the velocity, displacement from the velocity, so simply we can write the integration of v dt, the integration of v dt. And similarly from acceleration to velocity, if we have to get, so then the integration of a dt. So the reverse process we go for. Okay, so if you need, I'll solve it. I solve this. See here. So we know that v is equals to ds by dt. v is equals to ds by dt. So now what I am doing is, so ds is equals to v dt. ds is equals to v dt. So now integrate either side. So integration of ds is equals to integration of v dt. So now we know that, so integration differentiation are anti, so they both cancel. So the displacement is equals to, so the integration of v dt. So integration of v dt. Clear? Chalo. So and then next, similarly, if you take acceleration, we know acceleration is equals to dv by dt. Now, so I can write dv is equals to a dt. dv is equals to a dt. So then integrate, so the integration of dv is equals to integration of a dt. So integration differentiation cancels, so the velocity is equals to the integration of a dt. So if acceleration is given as a function of time, so if they ask you to find velocity, so simply integrate the acceleration, right? So and velocity is given as a function of time, so they asked you to find the displacement, so then simply integrate the velocity. So from acceleration, if they ask you to find directly displacement, first integrate, you get the velocity, again integrate, you get the displacement. Clear? So let me write this slide again in NEET. So here, so the displacement from here to here, velocity, and from here to here, acceleration. So now, so the displacement to velocity, differentiate, and velocity to acceleration, differentiate, and then reverse process. So if we have to get velocity from acceleration, so integrate, and from velocity to displacement, so integrate. So now, so what are these meanings? Let's write the meanings of these. So what is a differentiation? Differentiation is nothing but the slope of the curve, right? So now ds by dt. So what does that mean? The slope of st curve. The slope of st curve, it results in the velocity. And then, so what is dv by dt? The slope of vt curve. So the slope of vt curve, which results in the acceleration. This part we already know. So now the new part is, so what is the integration meaning? we have discussed in the basic maths. So the integration is nothing but the area under the curve, right? So simply now I can go for the area under VT curve, area under velocity time graph, so will result in the displacement, or if the body is moving in the straight line, we can say the distance also. So the distance as well. When the body is moving in the straight line, the distance or displacement both will be same, right? So and then what is integration of a dt? So what does this mean? So the area under AT curve, area under acceleration time graph or acceleration time curve, so which results in the velocity. Clear? So this part, what is differentiation, what is integration, and how do we get the velocity from displacement and acceleration from velocity or displacement, or how do you get the velocity from acceleration or displacement from velocity or displacement from the acceleration. So these terms are clear, so no doubt here. Chalo, so let's move further. Now let's solve some questions based on this reverse process, integration process. So let's go for the first question here. So what's the question says? See here. If the velocity of a particle is v is equals to at plus bt square, so where a and b are constants, then distance traveled by it between 1 second and 2 seconds. See here. So velocity function is given. At plus bt square is a velocity function. Now, so they are asking to find the distance traveled by it between 1 second and 2 seconds. So what are these 1 second and 2 seconds? So these are the limits of integration. So see here, we have to find what is the distance traveled. The distance traveled, let it be s is equals to how much? Now, so we know that s is equals to integration of v dt. S is equals to the integration of v dt. So from there, s is equals to, so integrate from where to where? 1 second to 2 seconds. What is the velocity function? At plus bt square. At plus bt square. So into dt. So now let's do the integration process. Everyone are familiar with the basic maths, right? So now see here. So the integration s is equals to integration 1 to 2. So we can write this as a t square by 2. So or else let's write individually. So to avoid the confusion, so let's write individually so that you'll understand better. So the integration of 1 to 2 at dt and plus integration from 1 to 2 bt square dt. So now see here, the displacement is equals to, so a is the constant and t integration is t square by 2. So from where to where? Right, 1 to 2 plus, so b constant, take it out. So t square integration t cube by 3. So from 1 to 2, right? So t to the power 1 plus 1 by 1 plus 1, and then t to the power 2 plus 1 by 2 plus 1 in the denominator, right? So now s is equals to a into, so substitute upper limit minus lower limit. So then it becomes 2 square by 2 minus 1 square by 2. So plus b into, so this is 2 cube by 3 minus 1 cube by 3. So 2 cube by 3 minus 1 cube by 3. So from here I can write the displacement is equals to a into, so this is 4 by 2. So 2 minus 1 by 2. So then plus 3b into, so 8 by 3 minus 1 by 3. So now I can write this as, so 2 minus 1 by 2. So 2 minus half, it's a 3 by 2. So that means 3a by 2 plus, so this is 7 by 3b. 7 by 3b. So this is the displacement function. Check the options. 3a plus 7b, no. Say 3 by 2a plus 7 by 3b. Yes, option B is the correct one. Clear? Understood everyone? Chalo. So let's move further. So let's go for the next question. What's the question says? Ignore the question number, guys. So whatever the leftover questions are there from the previous PPT, I took them. So just ignore the question numbers here. So if the velocity of particle is given as, if you want to count the question numbers, so just continuation of the last lecture it is. Okay. So if velocity of the particle is given as v is equals to t plus 1. Next. So find the displacement of the particle at the end of 4 seconds if initially particle is at origin. If the initially particle is at origin means at time t is equals to 0. So body's displacement is 0. Initially it is at origin. Right. So that means what are the limits? So initially origin. So that means 0 to 4. So the limits are 0 to 4. What they asked us to find? Displacement. Which function they gave? Velocity function. So velocity to displacement. So simply the integration of v dt from where to where, the limits are also given 0 to 4. So just proceed, guys. S is equals to the integration from 0 to 4. Velocity function is t plus 1 dt. T plus 1 dt. So from here the displacement is equals to, so then integrate this one. So t square by, so or else if you need you can write individually, your wish. So 0 to 4, so t dt plus 0 to 4 1 dt. So then, so the displacement is equals to, so t square by 2 from where to where? 0 to 4 plus, so this is t from where to where? 0 to 4. So then, so the displacement is equals to, this is going to be 4 square by 2, so minus 0 square by 2 plus, so this is 4 minus 0. So then S is equals to, we get, so 16 by 2 8, 16 by 2 8. So then this is going to be 0 however, plus 4 minus 0 4. So 8 plus 4, so 12 meters. 8 plus 4, so 12 meters. Option A is the correct one. Clear? Understood, guys? Everyone? Simple questions. Next. So let's go for the next question. So pause the video and try it on your own. If acceleration of the particle is given, acceleration A is equals to 3t square. So then find the velocity of the particle at t is equals to 3 seconds if the initially particle was at rest. So at time t is equals to 0, so the body's displacement is 0. Initially the particle is at rest, right? So what are the limits? 0, t is equals to 0 to t is equals to 3. So if you want you can write t1 is equals to 0 seconds to t2 is equals to 3 seconds, right? So now, so acceleration function is given, find velocity. So velocity is equals to a dt, integration of a dt, yes or no? So now from here, so we can write v is equals to, so the integration of, in place of a, 3t square dt. So then v is equals to, so 3 is the constant and t square integration is t cube by 3, right? So then from where to where, what are the limits? So from 0 to 3 seconds. So write the limits. So if you write the limits, no need to put the plus c, okay, na? So you know that process, right? Next. So then do the calculation here. V is equals to 3 into, so we have got t cube which is 3 cube by 3. So then 0 cube by 3. So however 0 cube is nothing but 0, so that comes out to be, this whole part is 0. So v is equals to 3 into, so I can write 3 cube by 3. So here 3 cancel, so 3 cube, so 9 into 3, 27 meter per second. So it's 27 meter per second. Option C is the correct one. Clear? Understood, everyone? Clear, guys? Done. Chal. So let's move for the next question. A particle initially at rest moves along the x-axis. Its acceleration varies with time. So acceleration is given as a function of time, right? So if it starts from the origin, so the distance covered by it in 3 seconds, see here. So body initially starts from the origin, and then the distance covered by it in 3 seconds. So the acceleration function is given. They are asking the distance, not the velocity. So distance to velocity, velocity to acceleration. So that means first you have to integrate acceleration. So then we get the velocity. Again integrate that, we get the distance or displacement. Yes or no? So now do the process. So what are the limits? T1 is equals to 0, T2 is equals to 3 seconds. Right? Chalo. So now, so first find the velocity. Velocity is equals to integration of 4t dt from where to where? 0 to 3. Now, so or else first find the velocity function itself. So v is equals to integration, so 4 t square by 2, 4 constant, t square by 2. So then it comes out to be, so 2 2s are, so let's put c. So then v is equals to, so this is going to be 2t square plus c. So and again integrate that, so we get the displacement. So the displacement is equals to integration of v dt. So now the distance covered by it in 3 seconds. So that means 0 to 3 seconds they are asking. 0 to 3 seconds. Now see here, s is equals to, so the integration of v, so 2t square. So however constant integration is going to be 0, so don't write that. So just write dt. So now from where to where? 0 to 3. So from here I can write, so this 2 comes out, which is t cube by 3. So from where to where? 0 to 3. So then s is equals to 2 into, so t cube, so 3 cube by 3. So however this part is going to be 0. So then s is equals to, so 1 3 cancel, 9 into 2, so 18 meters. Yes or no? So this is 1 3 cancel, 3 square will remain. So 3 square into 2. So 3 square is 9, 9 into 2, 18. So this is a correct answer, 18 meters. So option B. Clear everyone? So let's move further. Now, so let's go for the next part. So which is important question which was asked in NEET 2017, and this is going to be a standard result which you should remember. We should remember it as a standard result. So first understand the question. So Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator in time t1. So first in case 1, let's write case 1 where, so she reached the metro station. Let's suppose she reached the Amirpet metro station. Okay na? So she here is Preeti, beautiful Preeti is here. So now see here, so when she reached the metro station, this escalator was not working. Okay, let the total distance she has to climb from the starting step to the top. So let the total distance she has to climb is x. So now she walked up the escalator now. So let's suppose she took t1 time as per the given question. Now on the other days, if she remains stationary on the moving escalator, so then the escalator takes her up in time t2. So now case 2, in the remaining days, so the escalator used to work, right? So on that day the escalator was not working, so she has to climb up the escalator. So now on remaining days, so she just used to simply stand on the escalator so that she will reach the top, right? So now she stands here, then so again the distance is going to be same. So because from bottom to top she has to reach, so the distance is going to be x itself. So in this case, so she is taking some time t2 now. So now what's the next case? So then the escalator takes her up in time t2. So the time taken by her to walk up on the moving escalator, so the case 3. What's the case 3? In case 3, so she is in a hurry, she has to catch the metro train. Okay, so then what she is doing is, the escalator is moving and she is also climbing the steps. Escalator is moving, at the same time she is also climbing the steps. So in that case, how much time she takes to reach the top? So let the time be t. So however, the distance is going to be same. From bottom to top, the distance is going to be same. So now, see here, so we have to find time t in terms of t1 and t2. In terms of the first case and second case, we have to find the time, the total time. So first, understand the question properly here. The distance that she is traveling here is x distance. She is taking some time t. So here, the Preeti is walking. She is Preeti. Here, Preeti is walking. Let's suppose she is walking at a distance v. Escalator is at rest. Escalator is at rest. She is walking with a speed v. So now we know that speed is equals to distance by time. Speed is equals to distance by time. So from here, so the time taken by her will be equals to, so the distance by the speed. So let it be the equation number 1. Let it be. Now in the case 2, see here, she is moving a distance x, same distance. So now taking time t2, but the Preeti is at rest. Escalator is moving. Let the escalator speed be u. So let's write here. So let the escalator speed is u, meter per second, and then let the Preeti is walking at a speed of 8 v meter per second. So now she is stationary and only escalator is moving. So then in this case, so the speed u is equals to the distance traveled by the time taken. So from here, the time t2 is equals to distance by the velocity, which is x by u. So let it be equation number 2. So now let's come to the case 3. So let's come to the case 3. So where in case 3, again I am drawing the diagram. So this is a escalator, and then here is Preeti. So Preeti is walking. Preeti is walking. What is the Preeti speed? V. So V meter per second, Preeti is walking, and at the same time escalator is also moving. So with a speed of u, with a speed of u. So now in this case also, the distance is going to be same. This distance will never going to be changed, right? So the distance is going to be same. So and let the time taken be t. Let the time taken be t. So again use the formula. So the total speed, in this case, the total speed, which is going to be u plus v. Escalator speed plus, so the person speed, right? U plus v. So now we know that the speed is equals to the distance by time. Let's write step by step so that you will understand clearly. So distance by time. So then speed, which is u plus v, is equals to distance. So the distance is going to be remain same. So x by the time taken, let it be t. So now we have to find time t. So for that, what I am doing is, let's make the t as subject. So t is equals to, so I am writing x by u plus v. X by u plus v. So now let's do one thing, x by u plus v. So let's do one thing. So we have got what is u and what is v. We have got what is u and what is v. So from here v is equals to x by t1, and from here u is equals to x by t2. Let's write in terms of t1 and t2. So what I am doing is, so t is equals to x by, so in place of u I am writing x by t2, x by t2, plus in place of v I am writing x by t1, x by t1, because we need t in terms of t1 and t2 only. So then I can write t is equals to x by, so let's take x common in the denominator part, so that 1 by t2 plus 1 by t1, so that x gets cancelled. Yes, so then t is equals to, so then I can write 1 by, so let's take the LCM here, t1 t2 is the LCM, so that here t1 plus t2, so this t1 t2 goes up, so the total time t is equals to t1 t2 by t1 plus t2, t1 t2 by t1 plus t2. So that's a total time taken. So t1 t2 by t1 plus t2. So t1 t2, no, t1 t2 by t2 minus t1, no. So T1 T2 by T1 plus T2 or T2 plus T1. Both are same. Clear? Option C is the correct one, guys. Understood? Any doubts here? So remember, this has a standard result. So the time taken is equals to T1 T2 by T1 plus T2. So where T1 is the time where the person is walking and the escalator is at rest, and T2 where the person is at rest and escalator is moving. So in T time the person is moving and the escalator is also moving. So whenever they mention the values, let's suppose she is reached in some 10 seconds here. So on the other day she used to reach up just in 8 seconds. So then find the time. So when she is walking and also escalator is moving. So directly you can substitute T1, T2 values in the given formula if the values are given for T1, T2. Understood, guys? Chal. So instead of going for the entire procedure, you can just remember the standard result. Done? Chal. Let's move further. So then the equations of motion. Till now, whatever we have seen, so the V is equals to ds by dt, and then the acceleration is equals to dv by dt, and then so the acceleration is also equals to v into dv by dx. V into dv by dx is the acceleration. So these equations are always valid. These equations are always valid. So what does it mean by always valid, sir? So whenever the acceleration is 0, our acceleration is constant, our acceleration is variable. If the acceleration is 0 or the acceleration is constant or the acceleration is variable, in all these cases these equations are valid. So in all these three situations these equations are valid. Okay na? So those are the equations of motion we have seen. So now let's go for the equations of motion under uniform acceleration. So we'll do that. So before that, let's solve this question. So the question is given here. Clear? Huh? So just I wrote that what are the equations of motion that we studied. So where these equations can be applied. So whenever the acceleration is 0 or constant or variable, all these cases these can be applied. So again we are going to study so the equations of motion only under constant acceleration or uniform acceleration. There will be some more equations will be there. So those equations also we'll study. But before that, let's solve one or two questions, then we'll go for equations of motion under uniform acceleration. So now a body starts from the origin and moves along the x-axis such that the velocity at any instant is given by, the velocity function is given 4t cube minus 2t. Now, so where t is in seconds and velocity is in meter per second. So what is the acceleration of the particle when it is 2 meters from the origin? Understand this statement properly. So when it is 2 meters from the origin, what does it mean by 2 meters from the origin? The displacement is 2 meters from origin. At this point we have to find acceleration. See, body started from rest. Let's suppose at u is equals to 0, the body has started. Now, so at 2 meters, from 2 meters here, what is the acceleration at this point? At this point, what is the acceleration? But we just know the velocity function. We just know the velocity function. So what I am going to do is, from velocity v is equals to, we have got 4t cube minus 2t, right? So from there, let's get the displacement. So the displacement is equals to v dt, integration of v dt. So then displacement is equals to, so integration of v, what is v function is given 4t cube minus 2t, 4t cube minus 2t. So from here, so s is equals to, what is the displacement is given? So 2 meters, they mentioned it in the question, right? So then so clear. So then integration of, what is this 4t cube? So let's write separately. So 4 into t cube by 4 minus 2 into t square by 2. Yes or no? So 4 into t cube integration is t cube, t to the power 4 by 4 minus 2 is the constant which comes out t square by 2. So here 4 cancel, 2 cancel, so that we get, so the function, so 2 is equals to t to the power 4 minus t square. So then we have to find the t value. So t to the power 4 minus t square minus 2 is equals to 0. T to the power 4 minus t square minus 2 is equals 0. So this is a biquadratic function. So what I am doing is, so let some k is equals to t square. Let some k is equals to t square. So now let's write in place of t to the power 4. So shall I write k square? K is t square. So k square means t square whole square, which is t to the power 4 again, minus, so this is k minus 2. So which is equals to 0. So then so what we can write, k square. So here, so just do the splitting the middle term method. So which we can write minus 2k plus k. So minus 2k plus k minus 2 is equals to 0. So from here k square minus 2k plus k minus 2 is equals to 0. So this is the thing we got. Yes. So now, so in the first two terms I am taking k common, so which is k minus 2, and then here 1 into k minus 2, so which is equals to 0. So from here k minus 2 into k plus 1, so which is equals to 0. So which is nothing but k is equals to 2 or k is equals to minus 1. Basic maths you know, right? Either this will be equals to 0 or this is equals to 0. So then if it is equals to 0, k will be equals to 2. If it is equals to 0, k is equals to minus 1. So what we assumed, what is k? K is t square. So t square is equals to 2 or t square is equals to minus 1. So which is not possible, this one ignore it. So from here we can write t is equals to plus or minus root 2. So just write it as root 2. Time negative we can't take. So just take t is equals to root 2 seconds. Now at this time what they are asking us to find? So find what is the acceleration. At this time find the acceleration. So we got velocity function which is equals to, what is that? 4t cube minus 2t. 4t cube minus 2t, right? So from here, so let's go for the acceleration. Acceleration is equals to dv by dt. So then d by dt of velocity, so which is 4t cube minus 2t. 4t cube minus t, 2t. So then what is this one? 3 into 4, 12 t square minus, so 2t, which is nothing but 2. So from here we get 12 into, what is t in place of t? Root 2 whole square minus 2. So from here 12 into 2 minus 2. So this is 24 minus 2. So which is 22 meter per second square. So the correct answer is 22 meter per second square, option B. Okay, so understand the procedure, guys. So velocity function is given, so they are asking us the acceleration. So you know that acceleration is equals to dv by dt. So that's fine. But when they are asking the velocity acceleration, when displacement is equals to 2 meters, so first find the displacement from the velocity and equate it to 2, and from there you get the t value. Then differentiate the velocity, you get the acceleration function. So in that acceleration function substitute this t is equals to root 2. So that means at this time the particle was at 2 meters. At that 2 meters you are finding the acceleration. Root 2, at that 2 meters you are finding the acceleration. Understood the concept? Clear? Any doubts? Chalo. So let's move further. So this is a good question, logic question. Chalo. So now, so the equations of motion under uniform acceleration, whatever the previous equations that I gave, these equations are always valid when acceleration is 0, acceleration is constant, and acceleration is variable. So but whatever the equations that you have studied in the grade 9th, right? So these are the equations of motion under uniform acceleration. So what does that mean? Acceleration to be constant. Acceleration should be constant, where u is the initial velocity of the body. Let's suppose a body has started from origin, so then they reach some velocity v, final velocity, or else let the initial velocity not 0, let it be u is the initial velocity, and let the acceleration of the body be a, and in some time t the body covers a displacement s. So its initial velocity is u, and after reaching some point its velocity is v. So then we have got three kinematic equations, we call them. So v is equals to u plus at, and then s is equals to ut plus half at square, and v square minus u square is equals to 2as, or v square is equals to u square plus 2as. So these equations you already know in the grade 9th itself, right? So and then where u is the initial velocity, v is the final velocity, a is the acceleration, and then t is the time, and then speed, s is the displacement, right? So here acceleration should be constant, that's called uniform acceleration. So in sometimes in the questions they might say, so upon applying the constant force, so whenever the force is constant, if they say the constant force, so what's the force formula? F is equals to ma. So however mass is the constant part. If the force is constant, the acceleration is going to be constant. If the force is constant, the acceleration is going to be constant. Whenever they gave constant force in the question, the hint is that the acceleration is constant or uniform acceleration. Clear? So let's see some questions based on this. So what's the question says here? The displacement of a body in 8 seconds starting from rest. So u is equals to 0. So t is equals to 8 seconds, and then so with an acceleration 20 centimeter per second square. 20 centimeter per second square. So find the displacement. So what is s is equals to? So simply s is equals to ut plus half at square we can apply. S is equals to ut plus half at square. So what is s is equals to ut? Initial velocity is 0, so this whole thing will be 0 plus half a 20 t square 8 whole square, right? So this is going to be 10. So s is equals to 64 into 10, so 640 centimeters. So the correct option is 640 centimeters. Option C, direct question. Next. So let's go for the next question. See here, a particle moving with uniform acceleration from A to B along a straight line has velocities v1 and v2 at A and B respectively. If C is the midpoint, so then if C is the midpoint, so between A and B, then determine the velocity of the particle at C. See here. So what they are saying is, a body is moving in a straight line path with uniform acceleration. See here, with uniform acceleration. So it is started at A, and then let's suppose it is moving to the point B. So now, so the body has velocity v1 at A and velocity v2 at point B. Okay. So then C is the exactly midpoint. C is the exactly midpoint. So now we have to find the velocity at C. So let the velocity at C be v. Let the velocity at C be v. So now see here. So let me consider this total distance is going to be x. Let's consider this total distance is going to be x. So then from here to here the distance is going to be x by 2, and from here to here, so the distance is going to be x by 2. Yes or no? So then, so let's consider, so what I am doing is, first let's take from A to C, I am taking the equations. So u is equals to v1, so v is equals to v, and then so the distance covered s is equals to x by 2. The distance covered from here to here, it is x by 2. So then, so I am writing the equations. The acceleration is uniform, let the acceleration be a. So I am taking the equation of motion, which is v square minus u square is equals to 2as. So just understand carefully. So v square, in place of v, it's v only. From here to here motion I am considering. Okay. So u square is v1 square is equals to 2a, the acceleration a and displacement x by 2. So from here v square minus v1 square is equals to 2a into x by 2. So don't cut this, so let it be. So this is the equation number 1. So now let's consider the whole motion. Let's consider the complete motion from A to B. From A to B, the initial velocity is v1, the final velocity is v2, the acceleration is a, the distance covered is s. So again, let me use the same equation, v square is equals to, or v square minus u square is equals to 2as, right? So from here, v square, the final velocity, which is v2 square, minus the initial velocity v1 square, which is equals to 2. The acceleration is uniform a, and displacement x. So let it be equation number 2. So now what I am doing is, so this is v square minus v1 square is equals to 2ax by 2. So and then this is v square minus v2 square minus v1 square is equals to 2ax. So let's write the first equation also here. What is that? V square minus v1 square. V square minus v1 square is equals to 2ax by 2, right? 2ax by 2. So let's do the same thing. So 2 into, send this 2 to this side, v square minus v1 square is equals to 2ax. Let it be the equation number 3. So now observe equation 2 and equation 3. Observe equation 2 and equation 3. So from 2 and 3, so we can say both are same, their RHS are same, so that we can equate their LHS. Their RHS are same, we can equate their LHS. So then here the LHS of this is v square v2 square minus v1 square is equals to, the LHS of this 2 into v square 2v square minus 2v1 square. So what we need v. So remaining everything, send it to the side. So 2v square is equals to v2 square minus v1 square. So if you send it to the side, 2v1 square. So here 2v square is equals to, so this is plus 2v1 square minus v1 square, which is v1 square plus v2 square. So then v square is equals to v1 square plus v2 square by 2. So from here v is equals to v1 square plus v2 square by 2. So under root. So this is a velocity at the midpoint. What is v? V is the velocity at midpoint. So therefore the velocity at midpoint is v1 square plus v2 square by 2 under root. v1 square plus v2 square by 2 under root, right? So remember this as a standard result. Remember this one as a standard result. Whenever they say the velocity at A is something, velocity at B is something, find the velocity at exactly the midpoint. At midpoint. So simply square root of v1 square plus v2 square by 2 under root. Clear? Sure. So let's take one question based on this. So the same question with the values. So what's the question says? See here. A car is moving along a straight road with uniform acceleration. Then see, this equation is valid whenever the uniform acceleration is there. Okay now. Next. So uniform acceleration, it passes through points P and Q. Points P and Q. So they both are separated by some distance. So with velocity 30 km per hour and 40 km per hour. So at P the velocity is 30 km per hour and at Q the velocity is 40 km per hour. So then they are asking the velocity of the car midway between P and Q. So exactly in the midway. So exactly in the middle. What is the velocity at this point? C. So let the velocity be V. So we directly know the formula now. V is equals to square root of V1 square plus V2 square by 2. That's it. So then do the basic calculations here. V is equals to square root of V1 square. What is V1? 30 whole square plus V2 square 40 whole square by 2. So from here I can write, so V is equals to square root of 30 square is 900 plus 40 square 1600 by 2. So V is equals to, this comes out to be 2500 by 2. So then 2500 is 50 by root 2, right? So then I can multiply, so into root 2, so into root 2. So then V is equals to 50 root 2 by 2. So which we can also write it as 25 root 2. So V is equals to 25 root 2 kilometer per hour. 25 root 2 kilometer per hour. Option C is the correct one. Clear? Understood? Chalo. So now next question. A particle starts its motion from rest. From rest, initial velocity 0. Under the action of a constant force. What does it mean by constant force? Uniform acceleration, right? Constant force means uniform acceleration. Then, so if the distance covered in the first 10 seconds s1 and that covered in the first 20 seconds is s2, so then they are asking us the relation between s1 and s2. So body's initial velocity is 0 and then acceleration is constant, a is constant. This is the given information. And then in first 10 seconds the body covers distance s1, let it be, and then in the and that covered in the first 20 seconds, so the body covers a distance s2. So let's solve this for, so I am taking s is equals to ut plus half at square. Okay, so now, so the distance covered, let it be s1. So in the first 10 seconds, however, the initial velocity is 0, this term is going to be 0, u0. So half a into t square. So in the first 10 seconds means t, substitute it as 10. So 10 square. So then this comes out to be s1 is equals to, so 100 by 2a, which is nothing, 100a by 2, which is 50a. This is s1. Then, so then find the same information, s2 is equals to ut plus half a t square. So what's the time? 20 whole square. However, this term is going to be 0 because the initial velocity is 0. So from here s2 is equals to half the acceleration. What is the acceleration? A, let it be. So this is 400. So 400 by 2, which is 200. So 200a. So s2 is equals to 200a. So s1 is 50a, s2 is 200a. So then what is the relation? I could see that s2 is equals to 4 times s1. Yes or no? 4 into 50 is 200. So s2 is equals to 4 times s1. Clear? Understood? Sure. So let's move further. So same type of question. Understand the question first. A particle travels 10 meters in the first 4 seconds, 18 meters in the next 4 seconds. Assuming constant acceleration, what is the distance traveled in the next 2 seconds? Last the question. See here how to solve this question. So first let's say this is a path of the body traveled, right? Chalo. So let's suppose the body has started from here. So in the first 4 seconds, let's consider t1 is equals to 4 seconds, first 4 seconds. So then it covered how much distance? 10 meters. Then, so 18 meters in the next 4 seconds. So then till here, so the time is t2, next 4 seconds. See, next 4 seconds. In the next 4 seconds, it covered 18 meters. So then in the next 2 seconds, how much distance does it cover? So first understand through the picture. So this distance from here to here, what is the total distance covered? Tell me. So from here to here 10, from here to here 18. So that means total from in the first 8 seconds. In first 8 seconds, the body has covered 28 meters. 18 plus 10. So body has covered 28 meters in the first 8 seconds. So now I need it in the next 2 seconds. So what I will do is, I will find the distance traveled in the 10 seconds. I will find the distance traveled in the 10 seconds. So then minus the distance traveled in the 8 seconds. This is the distance traveled in the 8 seconds. Distance traveled in the 10 seconds minus the distance traveled in the 8 seconds. So then we will get this part only. So therefore, so the distance traveled in next 2 seconds will be equals to S10 minus S8. So in 10 seconds, how much distance does it travel minus the distance travel in 8 seconds, so that we'll get the distance travel in the next 2 seconds. So now we have to get what is the distance travel in the 10 seconds. We don't know this. We know this distance travel in the 8 seconds is 28, but we don't know what is the distance traveled in 10 seconds. How do we find that? When you know U and T values. So T you know, so U and A values you should know. So how do we get further? They gave the hints. What are the hints? So catch the hints, guys. So what are the hints? Tell me. So the distance covered in the first 4 seconds, is equals to 10 meters. The distance covered in the first 4 seconds is equals to 10 meters. So now let's write the equation for this. So initial velocity U, let it be, so ut plus half a t square is equals to 10 meters. So let's substitute the values. So let the initial velocity be u itself. So in the time 4 seconds, so therefore 4 times u plus half, let the acceleration be a. So time we are considering it as 4 seconds, first 4 seconds. So then 10. So from here I can write 4u plus this is going to be 16 by 2, 8a is equals to 10. So let it be the equation number 1. Done. And then, so the next equation that I am going to use is, so the distance covered in the 8 seconds is going to be 28 meters. The distance covered in the first 8 seconds. So here body's initial velocity you are considering u. Don't take the next 4 seconds 18, because you don't know what is the velocity here. The initial velocity you don't know here, right? So that's why I am taking the first 8 seconds. Total distance 28. So here again ut plus half at square is equals to 28. So u, let it be t 8 plus half a 8 whole square 28. So then here 8u plus, so this is 64 by 2, so 32a is equals to 28. Let it be the equation number 2. So what's the equation number 1 we got? So 4u plus 8a is equals to 10. 4u plus 8a is equals to 10. So now what I am doing is, let's multiply this whole equation with 2 on either side, so that we get 8u plus 16a is equals to 20. So let it be equation number 3. Let it be equation number 3. So now what I am doing is, let's solve equation, so 2 minus equation 3 I am doing. Let's subtract equation 2 minus equation 3. What is the 2 equation? 8u plus 32a is equals to 28. And then, so the second equation 8u plus 16a is equals to 20. So then simply subtract minus minus minus. So plus 8u minus 8u cancel, and then 32 minus 16, which is 16a, is equals to 28 minus 28. 28 minus 28. So then from here a is equals to 8 by 16. So from here 1 by 2, so which is nothing but 0.5 meter per second square. We got the acceleration. So we need u value also. So how do you get the u value? So just substitute in any of these equations. So I am taking 8u plus 32a is equals to 28. Second equation I am taking. So let's write 8u plus 32 into this one half. Let's write half, which is equals to 28. So here 8u is equal plus, so this one 32 by 2, 16. So is equals to 28. So from here 8u is equals to 28 minus 16. So which is 8u is equals to 12. So from here u is equals to 12 by 8. So which is nothing but 4 3s are 4 2s are, right? So which is 3 by 2 is a u. So now you got u, and we got u is equals to 3 by 2 meter per second, or 1.5 meter per second, whatever you can write. So now can we find what is the distance traveled in 10 seconds? So the distance traveled in 10 seconds is half ut plus half at square. right? U is how much? 3 by 2 into time 10 plus half. A is 1 by 2 t square, so which is 10 square. So from here I can write, so this is going to be 5, so 3 5s are 15 plus, so this is going to be 100 by 4. Yes or no? 10 square is 100 by 4, so 15 plus this is 25. So the distance traveled is 40 meters in 10 seconds. So now what do we require? The distance traveled in the next 2 seconds. The distance traveled in the next 2 seconds. Understand the picture. So the total distance, this one we got how much? 40 meters. Now, so this total is 40 and in the 8 seconds it is covered 28. So now in the next 2 seconds, the distance traveled in next 2 seconds, will be equals to S10 minus S8. S10 minus S8. So what is S10? The distance traveled in a 10 seconds, 40. The distance traveled in the 8 seconds is 28. So which is nothing but 12 meters. So in the next 2 seconds, it covers a distance of 12 meters. Option D. Understood the procedure, guys? Clear? Sure. So let's move further. Now, so there are some additional formula for the uniform acceleration. So we know that V average, let's suppose, if a body covers initial velocity V, then final velocity V, initial velocity U, final velocity V, and it's moving with a uniform acceleration A, let's suppose. It's moving with a uniform acceleration A. So then the average velocity, so the V average is equals to, so U plus V by 2. The average velocity will be U plus V by 2 you can take. So now we already know that the V average is equals to total displacement by total time. Total displacement by total time. Understand carefully here. So total displacement by total time. So that is V average is equals to, what's the total displacement? S. So what's the total time? T. So therefore I can write the total displacement is S. So total time T is equals to U plus V by 2. So from here, so the displacement covered by the body in terms of initial velocity, final velocity and time is given by U plus V by 2 into T. U plus V by 2 into T. So this is also one of the important formula that you should remember. These two, this one and this one. Clear? So the V average, this one, and the displacement covered with the uniform velocity, uniform acceleration, sorry. Done? Chalo. So let's move further. So let's take one question, guys. See, the question solving is important. The concept, I can just wind up the total motionless straight line in 1 hour. But the number of questions that you solve, so that you can understand the concepts easily through the questions, right? So the velocity of a train increases uniformly from 20 km per hour to 60 km per hour in 4 hours. So the distance traveled by the train during this period. So they are asking distance. So initial velocity is given 20 km per hour. So the final velocity is given 60 km per hour. And the time is given 4 hours. So they are asking the distance traveled, S. So we know the relation between these two, right? So we can simply write S is equals to U plus V by 2 into T. So S is equals to U, which is 20, plus V 60 by 2 into time 4. So 2 ones are 2 twos are. So S is equals to 80 into 2. So which is nothing but 160 kilometers. 160 kilometers. Option A is the correct one. Simple question. So next, a particle moves in a straight line with constant acceleration. Constant acceleration. So that means uniform motion equations you can apply. So then it changes its velocity from 10 meter per second to 20 meter per second while passing through a distance 135 meters in t seconds. So the value of t is, see, so its initial velocity is 10 meter per second. So its final velocity is 20 meter per second. So the distance covered 135 meter per second, 135 meters. So then we have to find the t value. So again the same equation you can use simply. So the s is equals to u plus v by 2 into time t. So from here the distance that they gave, so 135 is equals to, so u plus v, which is 10 plus 20 by 2 into t. So from here we can write 135 is equals to, so this is 30 by 2, 15 into t. So t is equals to 135 by 15. So 15 ones are 15 nines are. So t is equals to 9 seconds. So t is equals to 9 seconds. Option D is the correct one, right? Chalo. So next. So if a car is at rest, initial velocity 0, so accelerates uniformly, acceleration is going to be constant, and then speed ups to 144 kilometer per hour. 144 kilometer per hour. So it covers a distance of s is equals to how much? S is equals to how much? So simply time is given. So time 20 seconds. So then what is the distance covered? So see the options here. The options are in meters. Here it is in kilometer per hour. So let's do one thing. Convert it to meter per second. So 5 by 18. So 18 ones are 18 8s are. So 8 into 5. So which is 40 meter per second. So now simply substitute it in the formula. So what's the formula that we know? S is equals to u plus v by 2 into t. So from here what is the distance covered? We have to find u 0, v 40 by 2. So time 20, right? So from here I can write s is equals to, this is 40 by 2, 20, 20 into 20. So which is 400 meters. S is equals to simply 400 meters. So option C is the correct one. Understanding, guys? So the concept is easy. So just do the questions properly. Chalo, so let's do the next question. A body moving with velocity u is stopped by the application of brakes after covering a distance s. So if the same body moves with velocity n times the u and same braking force is applied on it, so then it will come to rest after covering a distance. So here two cases we have to take. So here case 1, and then let's write case 2 here. Understand the question properly. So see here. So in the first case, a body is moving with a velocity u, initial velocity u. So is stopped by the application of brakes. So that means the brakes are applied so that the body will be stopped after covering a distance s. After covering a distance f. So if the braking force is applied, so the body will retard, right? So its acceleration is going to be in this direction. The acceleration retardation we call. So the acceleration a. So in this particular case, so let's write v square minus u square is equals to 2as. Okay. So the final velocity is 0. However, so minus u square is equals to 2as. From here, the distance covered s is equals to minus u square by 2a. Let it be the first case where it's a equation number 1. So now let's go for the second case. Let's go for the second case. See here. So if the same body moves with velocity n times the u, so its initial velocity now is n times the u. Previously it is u. Now it is n times the u. And same braking force is applied. So what does it mean by same braking force is applied? So with whatever the retardation it's slowing down, with the same retardation it's slowing down here. Understanding? With whatever the retardation it's slowing down in the first case, with the same retardation it is slowing down in the second case. Okay. So now see here, the acceleration is going to be same in the both the cases, or retardation we can call, your wish. Okay. So now see here. Here also the body will be stopped. So but here it is moving with some velocity, here it is moving with some more velocity, n times the u. Obviously it will cover some extra distance if you apply the same braking force. Let's suppose I am moving with some 40 km/h. I applied the braking force. Okay, so I have stopped after some 100 meters, let's say. Okay, so then if I am moving with the more speed, like let's suppose 80 km/h I am moving with, and same braking force I have applied, so not extra braking force, same braking force. So obviously my vehicle will stop after 100 meters, like more than 100 meters. Previously it is when 40 km/h was there, so it stopped at 100 meters distance. So now in the second case, when I increased the speed to 80 km/h, obviously my vehicle will stop more than 100 meters, right? So the same thing here. So let the distance after which it stops is s dash in this case. Okay, so now apply the same equation again. So v square minus u square is equals to 2as. Now from here the final velocity, however, 0 whole square is equals to initial velocity u, initial velocity is nu, it's, and then 2, acceleration is same in both the cases. Let the distance after which it stops is s dash. So from here I can write minus n square u square is equals to 2a s dash. So from here the acceleration a is equals to, I can write minus n square u square by 2 s dash. So let's write the equation for acceleration here, not for, because we need to do for the acceleration same in both the cases, right? Acceleration is equals to minus u square by 2s here. Let it be equation number 1. So now in equation 2, so we have got this. Let it be equation number 2. So now from 1 and 2, so the same braking force means same retardation. So same retardation is nothing but same acceleration also. So from here, from 1 and 2, retardation is nothing but negative of the acceleration, that's it. So here acceleration is coming negative. What does that mean? Body is slowing down, retarding. Here also acceleration is negative, braking force is applied, so body is slowing down. So let's equate these two. So we can write the first one, minus u square by 2s is equals to, so minus u square, n square u square by 2s dash minus n square u square by 2s dash. Let the distance, here it is s dash, right? So now from here I can write minus minus cancel, so u square cancel, 2 cancel. So then I can write the 1 by s, whatever the terms that are remained, let's write, so n square s dash. So let's write the cross multiplication, s dash is equals to n square times u, n square times s. So that means if you increase the speed by n times, so the distance after which it stops is n square times s. For example, just understand through an example so that it will be better. Consider I am moving with some 40 km/h. So now I have applied some braking force so that the vehicle has stopped after some covering some distance, let's say 50 meters. So in the case 2, let's suppose I am moving with some 80 km/h. 80 km/h. So the same braking force I have applied. So the vehicle has stopped after covering some distance. So the same braking force A I have applied. Okay. So now in this particular case, what is the distance covered in this one? So the distance covered simply n square times s. So what is n square? How many times the speed has increased? From here to here, the speed increased 2 times. So that's why 2 square. How much distance it is covered in the first case? 50. So that's why 4 into 50. So in the second case, it covers a distance of 200 meters before stopping. 200 meters before stopping. So if I increase the speed to 120 km/h, let's say, so then the n becomes 3. So 3 square into 50, 9 into 50 it will become. Understanding? So n square times the original distance. Clear this part? So remember this as the standard result. Remember this as standard result. Chalo, so let's see the next one. So a question is given here. So what's the question says? A car moving with a speed 40 km/h. So can be stopped after 2 meters by applying the brakes. So it's moving with 40 km/h. So let's suppose it stopped after 2 meters after applying the brakes. So if the same car is moving with 80 km/h, so if the same car is moving with 80 km/h, so what is the minimum stopping distance? So if the same braking force is applied, if the same car and same braking force, so obviously how much the speed is increased? 40 kilometers and 80 kilometers. N is equals to 2. So let the distance here, it is S dash. S dash is equals to N square times S. So N square, which is N is equals to 2 here. 2 square times the original distance after which it stopped is 2 meters, right? So then 4 into 2, so which is 8 meters. After 8 meters it stops. Option A is the correct one. Clear, guys? So that's it from my end in the motion in a straight line lecture. So in the next lecture I'll come up with the more standard results, and then graphs we'll understand in the next session, which is going to be a very, very interesting session. So where how to find the slope of a curve, how to identify the slope of a curve, like how to like read the graphs and solve the questions. So we'll do n number of questions in the next session. So till then, keep studying. All the very best, guys. Bye. Take care.